Good afternoon, students. Yesterday we have completed time, speed, distance, and we are going to start geometry today. In geometry, we'll begin with the 3D shapes. The basic 3D shapes we will discuss. So first we'll go with cuboid. Cuboid. So almost all the rooms, so our classroom is also an example of cuboid. It looks like this. And it's cuboid. We are going to find the number of vertices and the number of faces. Number of faces we can divide into two types: curved faces and flat faces, and then edges, straight edges, curved edges, and then let us write straight edges. These things we are going to find out. So cuboid, these corners are called the vertices. So this is a solid shape or 3D shape. So how many vertices are there for the cuboid? So the number of vertices of the cuboid is 8. How many curved faces are there? There are no curved faces. We can write 0. Flat faces, there are 6. Curved edges, there are no curved edges, 0. But straight edges, there will be 12 in number. So we can say there are 4 lengths, 4 breadths, and 4 heights. We call this dimension as length. We call this dimension as breadth. We call this dimension as height. So there are 4 equal lengths, 4 equal breadths, 4 equal heights. Together we can write the number of straight edges is equal to 12. So this is about cuboid. And then let us see what is cube. Cube. If all the 3 dimensions of cuboid are equal, then we can say it is a cube. So in cube, all edges are equal. So all the things are same as the cuboid. Number of vertices is 8. Number of curved faces is 0. Flat faces is 6. Curved edges is 0. And straight edges is 12. This is about cuboid and cube. And then we will discuss about cone. Cone looks like this. So buffoon cap is the best example of cone. So number of vertices. So there is only one vertex, and the vertex of the cone is called apex. So that is called apex. So only one vertex. And curved faces. So there is only one curved face which is running around it. Okay, that is one curved face. And flat faces, there is one flat face at the bottom. So this shaded thing is the flat face at the bottom, and it is circular in shape. So that is one flat face. And curved edges, so this is called curved edge because it is curved and it is forming a circle. So curved edges, there is one curved edge. And straight edges, there is no straight edge in the cone. We can write 0 here. And then I'll discuss about cylinder. Then any doubts in this particular topic, I'll clarify. So we'll take cylinder now. So cylinder is like this. So cylinder is like this. So number of vertices. There are no vertices for cylinder. It is 0. Curved faces. There is only one curved face which is running around it. That is one curved face. And flat faces, there are 2. One is at the top and another is at the bottom. There are 2 flat faces. And curved edges, there are 2 curved edges. One is at the top and another is here. So these 2 are the curved edges. 2. And straight edges, there are no straight edges for the cylinder. We can write it 0. So here, any doubts in this particular discussion from cuboid to cylinder, you may ask now. Yes, Nishil, any doubts? Nishil?
Sir?
Yes, Nishil.
Sir, what is meaning of CF?
CF means curved faces. I wrote in short form. CF means curved faces. FF means flat faces. See, for example, daily you'll be using the pad right on the chair, plank.
Yes.
So that will be flat. So it is a flat face. You
Sir,
take
mean
example of ball. Okay, any ball. Ball's surface is in which shape? Is it curved or flat?
sir curve.
Yes, that is curved face, and the example is flat face. Okay.
Sir, example ball like
Yes,
circle shape.
ball's face is curved or flat. It is curved.
Yes, sir.
Okay. Any other doubts, Nishan?
Sir, what is SE?
SE is straight edges. The edges should be straight. For example, you take a room, okay, where the two walls are meeting, you will have a straight edge, no? So like that, you count for cuboid, you'll be getting 12 straight edges. Okay?
Yes, sir. Sir means sir edges.
Yes, edges. Straight edges we have to count. Curved edges means they are also edges like a line only, but they are curved.
Okay.
Mayuk, you have any doubts? Mayuk?
So every mountain have cone shape.
Come again, every vertex has cone shape.
So no,
No,
sir. Every mountain has cone shape.
no. Mountain is in irregular shape. It's not exactly smooth, right? It is irregular in shape.
So
Okay?
means every house is there in cuboid.
There is no condition. You can prepare it in any other another solid form also, but most of the houses rooms will be in cuboid shape. Harshavardhan, what is your doubt?
Sir,
Yes.
sir, you will not discuss perimeter and area.
Come again?
Perimeter and area.
Yeah, I will discuss that is in mensuration next chapter. Here in geometry only we deal with the figures and their properties. No perimeter, no area. That will be in the next topic, mensuration. Okay?
Sir,
Yes.
sir, apex means the edge of cone.
Come again?
Sir, the apex means edge of cone.
Not edge. It is a vertex. Vertex of the cone is called apex.
Sir, vertex means where the corner.
Vertex means the point like corner shape, right?
Sir, where the two lines are joining there.
Come again?
Sir, vertex means where the two lines are joining is called vertex.
Vertex means wherever the point like structure is there, that is called the vertex.
Okay, sir.
Nishika, what is your doubt? Yes, Nishika? Nishika, you're not audible.
Sir, what is mean by apex?
Vertex means it is a point like structure wherever the faces are meeting or the edges are meeting, that is vertex. Sanvi? Sanvi, what is your doubt?
Sir,
Yes, Sanvi.
sir, we have sir, the volume cuboid and cube. We can find volume. How we can find volume for cone?
We can find volume for cone also, but it is not there in your syllabus. In 8th syllabus, you have that. But anyhow, volume we are not taking this chapter. We are going to take in the next chapter mensuration. So in mensuration, we are going to take perimeter, area, surface area, and volume. Okay.
Okay, sir.
So next chapter also will be having only cuboid and cube in your syllabus, not the other ones. Okay.
Okay.
So these are the first four figures, and we will continue after that. So after cylinder, we have more number of solid figures, 3D shapes. Let us take. So let me write the heading again. Yes, here after cylinder, we are going to discuss about prism. Okay. In prism, first let us start with the triangular prism. So what is triangular prism? Triangular prism means the base will be in triangular shape and the top is also in triangular shape and all the vertices are connected like this. So this is a triangular prism. So the example of triangular prism you can take is kaleidoscope. You know kaleidoscope. So you can see beautiful colors using a colored paper, insert and mirror shapes. So kaleidoscope is in the shape of triangular prism. So let's write vertices here and let's write curved faces, flat faces, curved edges, and straight edges. Okay, so number of vertices of the triangular prism, it is 6. See, 1, 2, 3, 4, 5, 6. So how many vertices are there for triangular prism? There are 6 in number. Curved faces, there are no curved faces. Flat faces, top, bottom 2, and lateral 3. Lateral means side. 3 plus 2, 5. Curved edges, there are no curved edges, 0. Straight edges, top 3, bottom 3, and side 3. Total 9. Next, let's take a quadrilateral prism. Quadrilateral prism. That means base is a quadrilateral. Base is a quadrilateral. That means having 4 sides. Top is a quadrilateral having 4 sides, and the vertices are connected like this. So this is nothing like a cuboid. If the base is in square or rectangle shape, then it will be also like a cuboid. So it will have the same properties as the cuboid. Number of vertices is 8, curved faces 0, flat faces 6, curved edges 0, and straight edges 12. And similarly, we can go for pentagonal prism also. Let's take that. Pentagonal prism. That means base is having 5 different sides. So let's say this is a pentagonal base. This is in pentagonal shape. Top is also in pentagonal shape like this, and the vertices are connected like this. So this is pentagonal prism. Number of vertices, top 5, bottom 5, total 10. Curved faces, no curved faces. Flat faces, top 1, bottom 1, and side 5, total 7. Curved edges, there are no curved edges, 0. Straight edges, top 5, bottom 5, and lateral 5, total 15. So like this we can take more number of sides also, hexagonal prism, septagonal prism, and so on. So you can write that, but these are the first few things: triangular, quadrilateral, pentagonal. You can continue from hexagonal also. Next, let us take pyramids. Okay, so pyramids are different from prisms. Prism, the base and top both are polygons, and the lateral faces are parallelograms. But for pyramid, it will be, let's take triangular pyramid first. Triangular pyramid. So base is in triangular shape, but the top is not a polygon. It is actually a point in the space. So the point is connected with all the vertices like this. So this is triangular pyramid, and it is also called tetrahedron. It is also called tetrahedron. Why? Because tetra means 4. It is formed by 4 flat faces, 1 at the bottom and 3 on the side. So total 4. Tetra means what? 4. Because this is the only solid which can be prepared by 4 flat faces, it is called tetrahedron. So the other name of triangular pyramid is tetrahedron. So I'm writing the heading again. So first we are going to write the number of vertices, curved faces, flat faces, curved edges, and straight edges. Okay, let's write the number of vertices. 3 at the bottom and 1 at the top. So total 4. Curved faces 0. Flat faces 3 lateral and 1 base. Total 4. That's why this is called tetrahedron, because the number of flat faces is 4. That's why it is called tetrahedron. And curved edges, there are no curved edges, 0. Straight edges, bottom 3, lateral 3. Total 6. Next, let us take a quadrilateral pyramid. In quadrilateral, we have so many types like square, rectangle, and etc. But it can be a regular normal quadrilateral also. So let's take, for example, if I take a square, okay, and you take a point in the space and start connecting to the vertices. So this will be a square pyramid. So in Egypt, we have the pyramids, Giza pyramid, and etc. They are in shape of square pyramid only. So the number of vertices at the bottom we have 4, and top 1, total 5. 5 vertices are there. Curved faces, no curved faces. Flat faces, base 1, lateral 4, total 5. Curved edges, there are no curved edges. Straight edges, bottom 4, lateral 4, total 8. We'll take one more pyramid and then we'll change the solids. So we'll take pentagonal also. Pentagonal pyramid. Pentagonal pyramid. Let's take a pentagon at the base. So having 5 sides, and they will be connected with a point in the space. So this is pentagonal pyramid. Number of vertices at the top 1, bottom 5, total 6. Curved faces, no curved faces, flat faces, lateral 5, base 1, total 6. And the curved edges, no curved edges, straight edges, base 5 and lateral 5, total it is 10. Like this we can continue with hexagonal pyramid and so on, but these are the basic ones. And then we have sphere and hemisphere also. So let's take even that. Let's start with sphere and hemisphere. Yes, first let's take sphere. So sphere is like a normal ball, okay? But don't think that it is a square, sorry, circle. Don't think that it is a circle. Circle is a 2D figure, but sphere is a 3D figure, okay? So for sphere, you imagine a ball is there. So let's write the number of vertices, curved faces, flat faces, curved edges, and straight edges, okay? Number of vertices, there are no vertices at all, 0. Curved face is 1. One continuous face is running around it, that is one curved face. No flat faces. And curved edges, no edges at all. Straight edge is not there, or curved edge is not there. There is only one thing, that is curved face, okay? And next, hemisphere. What is hemisphere? You take a sphere and divide it by a plane, like divide it into two parts, this first part and second part. Those two parts are called two hemispheres. When you take a sphere and cut into two halves, each one is called a hemisphere. So it may be drawn like this. So this is hemisphere. So like that, one more part will be there at the bottom. One more part will be there at the bottom. If you connect, they will become sphere. So we are concentrating only on one part. Okay, number of vertices. So there are no vertices, that is 0. Curved face. So the top smooth curve is there, no? That is one curved face. Flat face is at the bottom. It is nothing but the circle. And curved edges. So there is one edge which is a circle. This edge is there, which is running here. This is one curved edge. And straight edge, there are no straight edges, we can write 0. So after this we can discuss one important thing called Euler's formula. Euler's formula. So what is Euler's formula? Euler's formula is basically, it is satisfied by every polyhedron. What is polyhedron? Polyhedron means it is a 3D shape or a solid figure, a 3D shape bounded by only flat faces. If it is bounded by only flat faces, then it is called polyhedron. So Euler's formula is always satisfied by every polyhedron. But first of all, what is Euler's formula? The number of vertices plus number of faces is always equal to number of edges plus 2. So this is always true. That means for a polyhedron, what is polyhedron? It is a 3D shape bounded by only flat faces. No curved faces are involved. So out of number of vertices, number of faces, and number of edges, if any two are given without knowing the figure, we can find the third one. Okay, let's take an example. I'm taking first a cube. Okay, so cube is a polyhedron or not? Yes, cube is a polyhedron. Why? Because it is formed only by flat faces. Are there any curved faces here? No, only flat faces. Now let us check this Euler's formula is working or not. Okay, first let me find the LHS. What is LHS? V plus F. What is the number of vertices? There are 8 vertices. And faces, how many? 6. So I got 8 plus 6 is equal to 14. So LHS I got 14. Now RHS. E plus 2. Number of edges, how many? Let's write E plus 2. Number of edges is 12 and plus 2. Again we got 14. Therefore we got LHS equal to RHS. So we got the answer. V plus F is equal to E plus 2. Let's take one more example. One more example for polyhedron. Let me take a square pyramid. Okay. So square pyramid is bounded by only flat faces. There are no curved faces. Okay. Let's take a square pyramid and let's write the LHS. What is LHS? V plus F. Number of vertices are how many for the square pyramid? There are 4 vertices at the bottom and 1 vertex at the top, total 5 vertices, plus faces, 4 lateral, 1 at the base. So 4 plus 1 is going to be 5. So 5 plus 5 we got 10. And RHS, that is E plus 2. So E means what? Number of edges. So 4 at the bottom, 4 on the lateral side. So it is 4 plus 4, 8. So we got 8 plus 2 is equal to 10. Again, we got the same answer, that is LHS equal to RHS. So not only cube and square pyramid, you take any 3D shape, how many faces it may have, also any number of faces, but all the faces must be flat faces. Whenever a 3D shape is created by using only flat faces, they will definitely satisfy Euler's formula. What is that Euler's formula? V plus F is equal to E plus 2. V means number of vertices, F means number of faces, E means number of edges. So any doubts, you can raise a hand. Mayuk.
Sir,
Mayuk, any doubt?
sir, every mountain peak is apex.
Yeah, in a sense we can say apex, but there is no rule that it should be ending in a single point. It is a natural one, no? It can be irregular also.
Sir, hemisphere, which shape have hemisphere shape? Which thing have
I didn't get you. Hemisphere, what are you asking?
Sir, which thing have hemisphere shape?
Hemisphere, you can take a bowl. Suppose any food item is served, no? It too in some restaurant they will cover with a hemispherical bowl only. Harshavardhan,
Yes, sir.
yes, what's your doubt?
Sir, Euler's formula.
Euler's formula. What is the doubt in Euler's formula?
Sir, why sir LHS is equal to
Always it will be true. It is a property. Every polyhedron will satisfy this property. So
Yes.
you want to check any other solid? Can you tell me one more polyhedron, any polyhedron you wish? But the condition, it should be formed only by flat faces. Curved faces should not be involved.
Sir, means sphere cannot be?
Sphere you should not take, because sphere is have a curved face, no?
Yes, sir. Sir, cube.
Cube already I have taken.
Sir, cuboid?
Cuboid also we have V, F and E all same values. No, can you take any other polyhedron? Can you take prism?
Yes, sir.
Which prism you want? Triangular, quadrilateral, pentagonal?
Sir, pentagonal.
Pentagonal. That means let's take a pentagon at the base. Let's take a pentagon at the base and same pentagon at the top, and let's start connecting the vertices like this. So which shape is this, Harshavardhan?
Sir, pentagonal.
Pentagonal prism, right?
Yes, sir.
So is it formed by only flat faces or any curved faces involved?
Sir, only flat faces.
Only flat faces, yes. So LHS we want V plus F. Harshavardhan, can you tell me how many vertices are there?
Sir, 10.
Very good, 10. And faces?
Sir, 1. Sir, down 1 and sir, 7.
Very good, 7. Bottom 1, top 1 and lateral 5, total 7. Very good. 10 plus 7 is 17. Now RHS. RHS is E plus 2. What is E? E means number of edges. How many edges are there?
1, 2, 3, 4, 5. Sir, 10.
No.
Sir, why, sir?
For bottom 5, for top 5 and lateral also 5 edges are there.
Sir, how like lateral will be 5?
Is this an edge or not? This one?
Yes, sir.
Like that we have 5 now.
Sir, 15.
So it is 15 and add 2. 15 plus 2 is 17.
Yes,
Again
sir.
we got LHS equal to RHS.
Yes, sir.
That means is Euler's formula working for every polyhedron?
Yes, sir.
Yes.
Sir,
You should remember that.
means
Nishil, what's your doubt? Nishil?
Sir,
Yes, Nishil.
sir, one more example can I give?
You tell me, I will check Euler's formula. Can you tell me any polyhedron?
Yes, sir.
Yes, which polyhedron you want to take? Don't take curved face. It should be having only flat faces.
Okay, sir. Sir, triangular.
Triangular what?
Sir, triangular pyramid.
Triangular pyramid or prism?
Sir, prism.
You want triangular prism?
Yes, sir.
Let's take a triangle at the base and let's take another triangle at the top and let's start connecting. So is this a triangular prism?
Yes, sir.
Okay, let's take LHS, that is V plus F. Number of vertices, how many?
Sir, 6.
Very good. And number of faces?
Sir, sir, number of faces 3.
No. So this triangular face which I am shading is 1, and the top triangle face is 1, and lateral there are 3.
Yes.
Top plus bottom plus 3 total.
3, sir. 2, sir.
See, base is a flat face, top is a face, and lateral there are 3. Total how many?
Sir, 6.
Why 6? Base 1, top 1, 2. 2 plus 3 is 5 or not?
Yes, sir.
6 plus 5, that's going to be 11.
11.
Now RHS, we want E plus 2. E means what? Number of edges, no?
Yes, sir.
How many edges are there?
Sir, it is 1 minute.
How many edges are there? Edges means the lines. Count all the lines.
Sir, 6.
Not 6, 9. For base 3, for top 3, for lateral thing, the lines are there, no 3. Total how much?
Sir, 6.
3 plus 3 plus 3, how much?
3 plus 3 plus 3, 9.
9. So we got 9 plus 2 is equal to 11. Again, we got the same answer or not, LHS, RHS?
Yes, sir.
That means now you understood why Euler's formula is true for every polyhedron. You take any
Yes.
polyhedron. What is polyhedron? It is a 3D shape bounded by only flat faces. Then
Yes,
Euler's
sir.
formula is always satisfied. Okay?
Okay, sir, I understood.
Yes. So this is about the Euler's formula. Now let's. Is Abhiday, you have any doubts? Abhiday,
Sir,
yes, you have any doubts?
sir, if you take a square,
Square is not a 3D shape. Square is 2D shape.
sir, square,
You want square pyramid.
sir, prism.
Square prism. Square prism is going to be nothing but cuboid only. Okay? So it's again cuboid. You can use V plus F is equal to E plus 2. It's like cube only. Again you get 8 plus 6 is 14. 12 plus 2 is 14. Again they will become equal.
Sir,
Yes.
sir, we can take more than pentagon.
Yeah, you can take even hexagonal pyramid, hexagonal prism. You can try. So everywhere Euler's formula will be true. Okay?
Okay,
Okay,
sir.
Abhiday. But the only condition is it should be bounded by only flat faces. Okay.
Can you take example more than 5?
You want me to take hexagonal prism and check?
Yes, sir.
Okay. See, can you imagine hexagonal prism? See, this is pentagonal prism, right?
Yes,
Yes.
sir.
Now you think it is having at the base 6 faces. Okay. Now how many vertices will be there? 6 at the bottom, 6 at the top. Is it 12?
Yes, sir.
How many faces are going to be there?
Sir, 1.
Imagine and say, don't no need to draw.
Sir, 7.
Not 7. Top 1, bottom 1, and lateral 6. Total 8 no. Top is a face, bottom is a face, lateral there are 6, total 8.
Yes, sir.
Now E plus 2, how many edges are going to be there? Edges, for bottom 6 edges, top 6 edges, lateral 6 edges, total.
Sir, 7.
6 plus 6 plus 6,
Sir, 8.
18 plus 2. Are they equal or not?
Yes, sir.
So 20 equal to 20. I hope you understood now for every polyhedron is it satisfied?
Yes.
Okay, now let's try to solve some previous year questions based on 3D shapes. So there was a question in 2021 that is a big cube has each portion of 44 centimeters. Tiny cubes of 4 centimeters portion each are cut from that. Then how many tiny cubes will be formed that are surrounded by cubes on all the sides? Who will try this question? A big cube has each portion of 44 centimeters. Tiny cubes of 4 centimeters portion each are cut from that. Then how many tiny cubes will be formed that are surrounded by cubes on all the sides? Who will answer this? Yes, Daksh, can you answer? Read the question again. Daksh,
Yes.
Daksh, can you read the question?
A big cube has each portion of 44 centimeters. Tiny cube of 4 centimeters portion each are cutted from that. How many tiny cubes will be found that are surrounded by the cubes of all sides?
You understood the question or not?
Understood.
Okay, first, what shall I do?
A big cube has 44 centimeters.
Okay, let me draw a big cube that is having side is equal to 44 centimeters. Okay, let me draw here. Yes, this is a big cube having each edge is equal to 44 centimeters. Okay, Daksh, is this 44?
Yes, sir.
Is this 44?
Yes, sir.
Is this 44?
Yes,
So
sir.
everywhere the dimensions are 44. Okay.
Okay, sir.
Yes. Now, tiny cubes of 4 centimeters portion each are cut from that. That means this is divided into so many pieces like this. Like this, so many pieces are divided. Okay. Like this, so many pieces are divided. So you can divide them into small cubes, right?
Yes, sir.
By doing these small cubes, you can divide.
Yes, sir.
Yes. Now, like
Yes,
that, the small cubes are having what is the measurement of each side? 4 centimeters, right?
yes, sir.
Okay. Now, if I divide like that, suppose if I am making the divisions here, 1, 2, 3, like that, if I do here, so that this is 4, this is 4, this is 4, this is 4, and so on. So, how many cubes will be arranged here on the each side?
11.
Very good. 44 divided by 4, that is 11, right?
Yes, sir.
Very good. So I got here 11 cubes, 11 small cubes are arranged on this side, and 11 are arranged this side, and 11 are arranged this side, right? So total how many cubes are formed?
The 33.
No, don't add, multiply. Yes or no?
Sir.
See, suppose I am adding 3 dots in each row, like that I am creating 3 rows. How many number of dots are there? 3 plus 3, 6 are there, 3 into 3, 9 are there.
So 3 into 3, 9.
That's why whenever you're counting row wise and column wise, total count will be given by the multiplication or the addition.
So multiplication.
Multiplication. So if you multiply all of them, 11 into 11 into 11, that is 11 cube, you're going to get 11 cube is 1331 number of small cubes are formed. Out of
Yes,
all
sir.
the small cubes, they're asking how many cubes are surrounded by cubes on all sides. Okay?
Okay, sir.
You understood the question? Surrounding by all cubes only.
No, sir.
Okay, for example, there is a corner cube which formed here. This is one corner cube. Okay, this is one corner cube. That will be there no corner cube if you divide into all pieces.
Yes, sir.
Now tell me, is this corner cube surrounded by all the cubes only?
Yeah, no, sir.
No, because it is at the edge, right?
Yes.
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 And what about this corner? That is also not surrounded by cubes on all sides, right?
Yes, yes.
And at all the corners also no, right?
Yes, sir.
That means starting from this side and starting from this side, one row is deleted. Okay, starting from this side also one row is deleted. If you delete one row from each side, so in the 11 you have to delete one cube from that side and one cube from this side. That means how many cubes are left inside?
Sir, 9.
Very good. 9 cubes are left inside, right? Now you take any cube which is inside that, okay, after deleting whatever are left inside. So to count that, can we use this product 9 into 9 into 9?
Yes, sir.
So what is 9 cube? We know 9 cube. What
Sir,
is 9?
7. So
Yes,
720.
729. That means how many cubes are surrounded by all sides cubes only? 729. Which option?
So option B.
Option B. So actually this figure is not required. To make you understand, I have drawn this figure and I explained like which one cube we have to eliminate from one side and the side. It should be visualized in your mind and then solve, right? I hope you understood the solution now.
Yes, sir.
Okay, so this is how we are going to answer this. So this is 729 cubes are going to be there because we are going to subtract 2. Okay, next question is a very simple question. Direct and simple question. Who is going to answer this? So before I answer the next question, first of all, any doubts in this previous solution, you can raise a hand. Priyash, you have any doubts?
Sir, no, sir. I want to answer the question.
Okay, answer the next question. Read the
Sir,
question.
how many faces are there in a cuboid?
Yes,
There 6 faces.
6. So for those who don't know what is cuboid, I'm drawing once again. So cuboid looks like this. Now you can count all the faces. So most of the rooms in the building are in cuboidal shape only. You can count each side wall as a face. The floor is a face and the ceiling is also a face. So total number of faces are going to be equal to 6. So it's going to be 6. Correct answer. Sriyansh, you can mute. So there are 6 faces in a cuboid. So this is about the 3D shapes you have to remember. And then the basic geometrical ideas we are going to discuss like point, line segment, ray, etc. First we discuss about point. What is point? Point is a very small location. Actually, it is not having any dimension. There is no length, breadth, or height. Okay. It is used to specify only the location. Okay. Other than location, there is no use of point. Okay. So how points are named? So there are different points, and I want to name different points with different names. We can name point A, point B, point C, D, etc. So use capital English letters only, capital English alphabet only. Don't use small. For points, you must use capital English alphabet only. Okay. So this is about point. And what are the examples of point we can take? The distant stars, they look like point. And when you put a dot with a sharp pencil, it also look like a point. Okay. And so point is having how many dimensions? No dimensions, no length, no breadth, no height. So no dimensions. And next, let us discuss about a line. So what is line? Line is a straight thing extending in both the directions. Actually, it is an undefined term in geometry, but we we visualize it like a straight segment extending in both the directions. Okay. So there are two basic ideas associated with a line, that is its straightness. Straightness. It should be straight, and extension, it should extend on both the sides. Okay, and extension. If any one basic idea is missing, it cannot become a line. And next point is something like how to name a line. Okay, naming of a line can be done in two different ways in geometry. The first way is, before discussing the naming, how many points are there on a line? Infinitely many. You take, this is a point on the line, this is a point, this is a, so many points, infinitely many points are packed on a line, and that is called density property. What is density property? Density property means you take any two points on a line, distinct or different points, between them you can again have infinitely many points. So you can understand how closely or how densely the points are packed on a line. So even in the small portion, infinitely many points are possible because points are dimensionless quantities. Okay, so you take any two points, we have infinitely many points on the line. You take any 2 points. I'm taking 1 point here and I'm taking 1 point here. Let us call this is A and let us call this is B. Then what is the name of this line I can give? Line AB. Okay, or line BA. So the correct way of calling this is line AB. Don't say AB line. You should say line AB or line BA. And there is one more way of naming this line. So if you don't want to use the points on the line, you can use a small letters like L. You can call it line L. Simply use L. So whenever you are using small letters, don't use this arrow mark above. Only it is used for capital letters. So whenever you are using a single letter, don't use the arrow mark. For example, you have a line here, you have a line here, you have a line here, and you want to give different names: line L, line M, line N. So using single small letter also we can name a line. That is either using 2 points or using a single letter also. And the next point is about its end points, number of end points. Number of endpoints. How many endpoints are there for a line? 0. Because it is extending on both the sides, it is not stopping anywhere to have the endpoint. So it is keeping on extending on both sides. So number of endpoints is going to be 0. So in this discussion, any doubts can raise a hand, then we'll move ahead. Jashvi, any doubts? Jashvi, any doubts?
Sir, what is it straight?
Straightness, NESS, straightness.
Okay, sir.
Neeraj, any doubts? Neeraj?
Sir?
Neeraj, you have any doubts?
No, sir.
You raise
Sir,
your
I have a previous question doubt, sir.
Which previous question? The number of small cubes, that one?
Yes, sir.
You didn't understand that?
No, sir. I was.
Okay, without drawing the figure, I'll make you understand. You see, for example, you have prepared a very big cube, okay, which is a 44 centimeters having each side, okay. Okay.
Okay. Okay.
Then what you did is you want to divide it into 1331 cubes. So 11 cubes will be arranged on each edge. So the big cube is divided into so many small cubes. You can imagine that.
Yes, sir.
But before dividing, what you did is you painted on all the faces of the big cube. Okay.
Yes, sir.
Okay. Now, after you divide into so many pieces and you open all the small cubes. Okay. Now,
Yes.
how many faces are not painted? See, the cubes which are arranged at the boundary, they receive out of 6 faces, 1 face will be painted, right? Because you painted on the outer surface.
Yes, sir.
But the cubes which are there inside that boundary are not receiving any paint, right?
Yes, sir.
Why they are not painted? Because they are surrounded by all the smaller cubes before you divide, right?
Sir, yes, sir. Sir, in each face, how many squares are there, sir?
Come again. I didn't get your question.
Face, how many squares are there?
In each face 121 will be there, because in one edge 11 are arranged. In each face 11 into 11, 121 will be arranged. Okay.
Sir, 484 were painted, sir.
Not 484. See, the total boundary layer you have to remove. Okay. Because 11 cubes are arranged, no. The
Yes,
top
sir.
one will be painted at the top, bottom one will be painted at the bottom. Those two should be removed. That means in every row 2 are deleted, right?
Yes, sir.
11 minus 2 is going to be 9.
Yes, sir.
That means it is again like a medium sized cube inside that 11 sided one. Okay. 9 into 9 into 9. That's why 729 cubes will be inside that boundary. That's why they are not receiving any paint. And so we can understand that they are surrounded by only small cubes. All sides small cubes. Okay.
Okay, sir.
Okay, Neeraj. Now, my doubts?
Sir,
Yes.
why will you use capital letter for point?
Come again.
Sir, why we will use capital letter for point?
That is as a notation all the mathematicians are using, so that everybody is using their own rules. Then it will be very confusing for us to communicate between the people, right? That's why we are following the same set of notations. Okay. Vishnu, your doubts? Vishnu? Vishnu?
Sir,
Yeah, what's your doubt?
sir, can a line be less dense or more dense with points?
Actually, you take a small region on the line or you take a large region on the line. Even though a small region on the line contains infinitely many points, that is possible because point is dimensionless, very, 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 very small. Okay.
Uh, eh, sir, can it be like
Sand is less dense and the soil is more dense.
Come again.
Sir, can it be like sand is less dense and soil is more dense?
You cannot compare sand particle with point, because sand particle is, you can feel that by touching. It is having some dimensions, having some length and some breadth. But point, to be precise, it is not having any dimension. It's very, very, very thin. It's showing the location, but it is still not having any finite length, breadth, or height. Okay, it should be very, very small. Actually, we say it is an imaginary concept only. There is no physical thing like that. Okay.
Point.
Harshvardhan, what's your doubt?
Sir, why sir we can fill infinitely many points in the
Because point idea is created in geometry to specify location only. That means only location is specified. That's it. It is not having any width. Okay.
Sir, why point no not have dimensions, sir?
Because it is designed like that. The idea of point is to show only location. So location is specified using a small thing. It is not having any width. If it is having width, it may become a circle. Circle is having area, but point is not having any area.
Okay.
Okay. Abhiday. Abhiday.
Sir, I didn't understand extension.
Extension is the line extending on both sides or not?
Yes, sir.
That's why it's having the property of extension. That's it. Okay.
Okay, sir.
Sanvi. Sanvi.
Sir,
What's your doubt?
sir, density property means what, sir?
Density property means, see here. So I have a line. Okay.
Okay,
So
sir.
let's take this line L. On this line, how many points are there?
Sir, 2 points.
No, infinitely many. See, how can you imagine? See here, I'm taking a dot here, okay?
Okay, sir.
Again, I'm taking a dot very close, but towards its right. Very close towards its right. Like by putting all the dots like this, if I fill all the dots, ultimately it's going to become a line or not?
Yes, sir.
That means on the line, how many points are there?
Sir, infinity.
Infinitely many, right? Now you take any 2 points which are very close also. Let's take a point here. Let's take a point here and I'm calling it X. Let's take a point here and I'm calling it Y. Now my question is, between X and Y, how many points are there on the line?
Sir, infinitely.
Yes, infinitely many. That means how close they are or how far they are, no problem. Between them, again, infinitely many points are going to be there. That is called density property, because the points are so densely packed on the line. Is it clear?
Yes, sir.
Possible because point is dimensionless. Okay, next. Sriyash, what's your doubt? Sriyash,
Yes, sir.
what's your doubt?
Sir, what is the difference between line and point?
Line is a one-dimensional figure and point is zero-dimensional figure. There is no dimension for point, but for line, one dimension is given, that is length. Okay.
Sir, so many points together called a line.
Yes. Point is
Sir,
having only one point in it, but line is having infinitely many points arranged in a straight manner. That is line.
sir, you said point has no length, no dimensions. Then how line has a dimension?
Line is not having any length. Line is also having only one dimension, that is lengthwise. Okay.
Yes, sir, but does not have any length and breadth and height.
Yes, points are so densely packed, that they will create infinitely many points together. Is having the length of the line is infinite. See, for
Yes,
example, if we take part of a line, the part of a line is we are going to call line segment. See, line is different, line segment is different. Now, is this line segment having any length here? Something
no,
like
sir.
centimeter, 4 centimeter, etc.
Yes, sir.
Yes. How is this line segment formed? This line segment is also formed by the set of so many points only.
Yes, sir.
Because so many points are coming together to form some shape, it can be measured. Okay, line segment can be measured, but line cannot be measured as it is very large. That means length of a line is infinite, but length of a line segment is finite. Okay. Shriyash?
Yes, sir.
See, what I'm saying is length of the line is infinite, but length of the line segment is finite. Okay. Shriyash? Okay, you muted. No doubts left. Shriyash, can you unmute? Okay, we'll continue with that. So after the line, anything left? Yes, Shriyash?
Sir,
Yes.
sir, my voice is audible.
Yes, yes, clear.
Okay, sir.
Tell me.
Sir, nothing, sir. I am asking just my voice is audible.
Okay, no problem. So line we completed, straightness, extension, density property. Yes. Before we start ray and line segment, etc. About line, we need to study one more thing called um how will you decide betweenness. Okay. Now, there is a point A and there is a point B. Okay. And I want to check whether a point C is lying between them or not. Between means, I mean, if a straight path is joining A and B, if C is there on that straight path, I'll call C is between A and B. Suppose if C is somewhere here, I don't say C is between A and B. So how to check C lies between A and B? Can anybody say the answer? How to check a point C lies between A and B? How to check? Can anybody answer? No hands raising. Okay, no problem. So, Harshavardhan, yes. Harshavardhan,
Yes, sir.
how will you check point C lies between A and B or not?
Sir, because A and B we can draw a line, sir, and there you said that between line there between 2 points there are infinitely many points, sir.
No, not drawing and whether it is passing through or not. Not like that. Using any measurements. Using any measurements, can you check C is lying between A and B?
Sir, measurements.
Okay, let me answer this question. Then, based on that, I may ask the new questions later. First, listen to this. This condition is called condition for betweenness. Condition for betweenness. So, how can you decide a point lies between other 2 points? See, first let us join A to C and we find the length of AC and then we also find the length of CB. Suppose if you find AC and CB and add, if this sum equal to the distance AB, then definitely C lies between A and B. For example, in case 2, if A is here and B is here, but C is here, okay, that means A to C we calculated the distance, C to B we calculated the distance and added. So in this case, it's going to be greater than AB. Okay. So in this case, AC plus CB is going to be greater than AB. Why? Because the straight path is the shortest path and any other path like A to C and C to B will be greater than the shortest path. So we can say AC plus CB is greater than AB. That means we got a condition now. Whenever AC plus CB is equal to AB, we can say C lies between A and B. And whenever AC plus CB is greater than AB, then we can say that C does not lie between A and B. So this is the condition. So what is the condition for betweenness? Whenever AC plus CB is equal to AB, we can say C lies between A and B. And in that particular order, we write ACB order. What do you mean by ACB order? A after AC comes and after CB comes. That is ACB order. Okay. And next, after this, we are going to discuss about ray. So ray is something like line only, but only one difference. So ray is also one-dimensional figure only, but it is having an end point. It won't extend on that side, but towards the other side it keep on extending. Okay. So this is ray. The difference between ray and line is line extends in both the directions, but ray it will not extend on one side. It has an end point, but on the other side it is extending. So ray number of endpoints you can write first. Number of endpoints is going to be only 1 because this is the endpoint. Okay, how to name a ray? Okay, suppose if I call this point A and you take any other point other than A, let us say this is B. Now what is the correct way of naming this ray? You take the initial point, and you remember this A is called the initial point. A is called the initial point of the ray. So starting from A, it is extending towards B. So you use a ray symbol above that. So you will call it ray AB. Don't say AB ray. You say first ray, then you say AB. That is ray AB. And you may be having doubt, sir, line AB, we wrote either line AB or line BA, both are same. But can I write it as ray BA? That is wrong, because this ray is not extending from B to A. It is extending from only A to B. So we cannot write in the reverse order. Only proper order we have to write, and the direction also should be correct. So this is how we name a ray. So ray is also a one-dimensional figure, and number of endpoints is 1. And that's it. Yes. So this is about a ray. And on ray also we have the density property is satisfied. What is the density property? On a ray we have infinitely many points, and between any two points again we have infinitely many points. That is density property. Okay, so this is about ray, and it extends only in one direction. And next we have the line segment. Line segment can be defined in geometry. Line segment is a defined term. Point is undefined, line is undefined, ray is undefined, but line segment is defined. In short, line segment can be called segment also. So let us understand what is line segment. Let us say this is point A and this is point B. So how many different paths are possible from A to B? I want to start from A and reach B. This is a path possible. This is a path possible. This is a path possible. And this is a path possible, like that. So many paths are possible to travel from A to B. But out of all the paths, if I ask what is the shortest path, it must be this, the straight path joining A and B. So we can say line segment, or we can define line segment as it is a straight path. It is a straight path joining two points. Straight path joining 2 points. The straight path is nothing but the shortest path. The shortest path joining 2 points A and B is the line segment AB. And how do we name the line segment AB? Just write a bar above it that indicates the line segment. So we can say the shortest path joining 2 points A and B is the line segment AB. Or we have a more formal definition, that is mathematical definition. We already understood what is when a point lies between other 2 points. Okay, so we can say the set of all points, the set of all points between A and B, including them. That means we should include A and B also. Including them is the line segment AB. So what is this definition? Okay, so let's take a point A here. Let's take a point A here, and let's take a point B here. We know the condition for betweenness. Suppose if there is a point C, something like AC plus CB equal to AB, then C lies between them. Similarly, we have one more point here, one more point, one more point, one more point. So many points are there between them. If you put all those points, ultimately it's going to become a line segment. And they said including them. So the endpoints must be included. That means A is included in that list, B also included in that list. So together, all of them will make the line segment AB. So this A and B for this line segments are called endpoints, or they're also called extreme points. Endpoints or extreme points, or they're also called extremities. They're also called extremities. So how many endpoints are there for a line segment? Now there are number of endpoints is 2. Number of endpoints is 2. For line it is 0, for ray it is 1, but for line segment it is 2. And naming can be done like either we can call line segment AB, or we can call line segment BA. For line we can change the order, for line segment we can change the order, but ray we cannot change the order. So line segment AB is always same as line segment BA. So this is about the line segment. So till here, any doubts? So any doubts till here? Can raise your hands now. Any doubts till line segment? So no hands raising, easy concept. So this is about line segment. Sanvi has a doubt. Sanvi, what's your doubt?
Can someone explain condition for betweenness?
See, Sanvi, it's very simple. I have, so let me go back. Yes, condition for betweenness. There are 2 points A and B. I have a point A here and I have a point B here. I want to check a point lies between A and B or not. So what is the condition I have to check? If I add AC and CB, am I getting AB or not? We should check. If it is equal to AB, then definitely C lies between them. For example, let's take AC is equal to 2 centimeter, CB is equal to something like, let's take 3 centimeter, then AB will be definitely 5 centimeter, right?
Yes, sir.
Why? Because C is lying between them. But if C is not lying between them, it is not possible, right?
Yes, sir.
I will tell you why it is not equal. See here, I want to start from A and I want to go to B. Okay.
Okay,
Yeah.
sir.
Okay. Now, what I'm doing is this is your home. Okay. And this is
Okay, sir.
your school. Okay. And while going from home to school, okay, you're already late, and you there are two options for you. Either you take this path A to C or C to B, or you take this path A to B. Which path will you choose?
A to B.
Why? Because it is the shortest path and you reach the school on time, right?
Yes, sir.
Yes. But from B to A, you want to come back. From school to home, you want to come back. But there is your friend's house. Okay, you already informed your mother. You will go to your friend's house and play there for 1 hour and come back. Now you are going from B to C and C to A. So which path took more time? Which path took less time?
Sir, B to C, C to A, more time.
Yes. Why? Because AB, the connecting path, if it is straight, that is the shortest path, right?
Yes, sir.
That means AC plus CB should be definitely greater than AB.
Yes, sir.
You can decide that C is not lying between A and B.
Yes, sir.
Is it clear?
So clear.
Okay. After line segment, we have these. Yes, are done. Any other things are left? Yes. We need to discuss plane and face also. Okay. Now we are going to discuss about the plane. Plane is also a basic idea in geometry, basic geometrical idea. So what is plane? See, I'm writing on this screen now. This screen is a plane for me. It's not a plane actually. It's a flat surface. But is it extending infinitely? Do I have that much big canvas to write? No. So you imagine the floor of your room wherever you're sitting. Yeah, it is flat, but is it extending in all directions? No, it is stopping at the wall. So it is an imaginary concept. If you take a flat face and which is extending in all the directions like this, okay, a flat surface extending in all the directions, that shows your plane. So there is no perfect example for plane in the real life. It is only imaginary concept in geometry. It should be flat and it should be extending in all directions. Then it is called a plane. So how to name a plane? Plane is named by any Greek letter, or we can call plane alpha. Or we use any three non-collinear points also. Like we can say point A here, point B here, point C here. So the 3 points should be not on the same line. They should be on the different line. Like, so you can see ABC. Can any line pass through them? No, they are non-collinear. So use any three non-collinear points. We can say plane ABC, or we can simply say plane alpha, or we can give numbers also like plane number 1, etc. Okay. So this is about plane. So plane is something like a two-dimensional figure, but it is extending in all the directions. It is infinitely big. And now finally space. Space is the thing which contains all the other things. In space, so many planes are there, so many lines are there, so many points. So space is the ultimate thing. Everything will be inside the space. and this is the something like three-dimensional quantity. Okay, infinitely big three-dimensional quantity, that is the space. So this is about the basic geometrical ideas. And in the line, I forgot to discuss one topic called collinear points and non-collinear points. So what do you mean by collinear points? Collinear points, in the name only it is there, co plus linear, collinear. Co is the short form for common. If the points are lying on a common line, we call them as collinear points. So what we can write, points lying on a common line, points lying on a common line are called collinear points. For example, we have a straight line, let us say this as line L. There is a point A, there is a point B, and there is a point C. So can we say A, B, C are collinear points? Yes, we can say that they are collinear because they are lying on the same straight line. But if I have a point D here, I want to check ABD. ABD are collinear? Is there any straight line passing through ABD? No. So they are called non-collinear points. If the points are not lying on the same straight line, we call them non-collinear points. So, and similarly, we have coplanar lines also. Coplanar lines. What do you mean by coplanar lines? Collinear points means points lying on a common line. Coplanar lines means lines lying on a common plane. Lines lying on a common plane. Suppose I have a plane, and in this plane I have some lines. Let us say line L and let us say line M, like this. So I can say L and M are coplanar lines. Coplanar means both of them are lying on the same plane. So how we have coplanar lines, we have coplanar points also. So let's say coplanar points. Coplanar points. So what do you mean by coplanar points? Points lying on a common plane. Points lying on a common plane. So you can say this is a plane and there is a point here, let us say A, let us say B, let us say C. So in this example ABC, if you see in terms of plane, we can say that they are coplanar. But if you see in terms of line, is there any straight line passing through them? No. Can you draw a straight line like this? No, it is not a straight line, it's a bent line. So straight line cannot pass through ABC. So definitely they are going to become non-collinear. So I hope you understood. Coplanar means they should lie on the same plane. Collinear means they should lie on the same line. So all the 3 points ABC are lying on the same plane. That's why they became coplanar. But all the 3 points are not lying on the same straight line. That's why they became non-collinear points. So any doubts up to here? Vishnu, what's your doubt? Vishnu, what's your doubt?
Sir, how to name a plane?
Come again?
Sir, how to name a plane?
Naming of a plane, I already told you, you can use any Greek letter, number, but the formal way of using naming a plane is use any three non-collinear points. What is the condition? Use any three non-collinear points to name a plane.
Sir, what is that? After that, some symbol is there.
This is alpha. This is the first alphabet in Greek letters. This is alpha. Okay, alpha, beta, gamma, some Greek letters will be there. Okay. Harshvardhan,
Sir?
doubts?
Sir, yes, sir. In sir, coplanar lines.
Coplanar lines, lines lying on a common plane. For example,
Yes, sir.
uh, what you do is, there is a wall, okay, in your house. Wall is vertical and it is a part of the plane. Okay, you're drawing two different straight lines on the wall. Then they will become coplanar or not?
Yes, sir.
Because they are lying on the same plane.
Yes, sir.
That's it.
Sir, I have a doubt in that line segment, but you not.
Line segment, you have doubt. Which doubt?
Sir, why, sir, shortest line is called segment?
Yeah, you can imagine that is the line segment is nothing but the shortest path joining any 2 points. See, There are so many paths I have drawn from A to B. Out of all the paths, I decided that the shortest path is the straight path. Any other path can you say which is shorter than that?
Sir, no.
That's why it is the shortest path we call straight path. Okay.
Okay, sir.
Next, Jeshvi. Jeshvi, any doubts?
Sir, I has doubt on non-collinear point.
Non-collinear points. What do you mean by non-collinear points? Points which are not lying on a same straight line. You see these 3 points, just be A, B, C. You see these 3 points. Can you draw a straight line passing through all the three at a time?
No, sir.
No, it's not possible. That means, are they lying on a same line?
No, sir.
That's why they are non-collinear. Manaswini, Manaswini,
Sir,
any doubts?
sir, this eight, sir, in collinear points and collinear lines, collinear points, sir, ABC is four planar and ABC is non-collinear. What is it, sir? I didn't understand.
Coplanar means lying on the same plane. Okay. Now, you check the last figure. The points, 3 points ABC, are lying on the same plane or not?
Yes, sir.
Yeah, that's why they are coplanar. But just now I answered Jeshvi. Are they lying on the same line?
No, sir.
That's why they are non-collinear. That's it.
Sir,
If they are
why?
lying on the same plane, you call them coplanar. If they are lying on the same line, you call them collinear. They are coplanar, but they are non-collinear. But if I draw something like this, okay, see here, we'll take one more example. Next example is something like, if I take like, so there is a plane and I have the 3 points like this. There is point A, there is point B, and there is point C. If a straight line is possible through them, okay. Now tell me, Manaswini, ABC are coplanar or not in here?
Sir, coplanar.
Yes, coplanar. Now I'm asking, are they collinear or not?
Sir, collinear also.
Yeah, they are collinear also. That means these 3 points are collinear as well as coplanar. But using these 3 points, you cannot name a line. Why? Sorry, you cannot name a plane. Why? Because plane should be always named by non-coplanar, sorry, non-collinear points only. Okay,
Okay, sir.
that's it. So we're done with basic geometrical ideas. And anything left? Yes, that's it. Okay. After basic geometrical ideas, we have types of angles. Okay. So about lines, we need to discuss some relations like intersecting lines and parallel lines. We discuss after solving some questions. So all of you, check the next question. 2021 exam, we got this question. A flat surface which extends indefinitely in all directions is called dash. Simple and direct question. Vishnuka, read the question again.
Sir,
Yes, read the question again.
a flat surface which extends indefinitely in all directions is called a.
Dash. What?
Sir,
Which answer?
sir, option A, plane.
Very good, correct answer. This is just the definition of plane I gave you. A flat surface extending in all directions is called a plane.
Plane.
The answer is A. Very good, Rishka, you can mute. Next question from 2020 exam. In the given figure, find the ratio of number of triangles to the number of circles inside the rectangle and number of squares to all the figures inside the rectangle. Who will answer this? Manaswini, read the question again.
Sir,
Read the question again.
in the given figure, find the ratio of number of triangles to the number of circles inside the rectangle and number of squares to all of the figures inside the rectangle.
Okay, first they're asking the ratio of number of triangles and number of circles. How many triangles are there?
Sir, three triangles are there, sir.
Three triangles are there. And how many circles are there?
Sir, two circles are there, sir.
Okay, next ratio. Um,
Sir, next ratio is
Number of squares. How many squares are there?
sir, two squares are there, sir.
Okay, to all the figures. How many figures are there?
Sir, seven figures, sir.
2 by 7. Which option?
Sir, option A.
Option A. Very simple question, no, Manaswini?
Yes, sir.
Okay. Just you should know the names of shapes. You can answer this question. So the ratio is 3 by 2 and 2 by 7. So next one topic we are going to discuss, that is the relation between the lines. Or you can say straight lines. Yes, straight lines. In this topic, first of all, we are going to discuss about two lines having a common point. So you see these two lines, this is line L and this is line M. So line L is having infinitely many points, line M is having infinitely many points, but these two lines have a common point. That common point is here. Okay, if we call it point O, so this point O is called point of intersection. Point O is called point of intersection. And what are these two lines are called? These two lines are called intersecting lines. Intersecting lines. So lines that have a common point are called intersecting lines, and the common point is called their point of intersection. But if more than two lines are there, like let us say this is line L, and let us say this is line M, and let us say this is line N. So here more than two lines are passing through a same point. Let us say this is point O. Now we say that point as point of concurrency. Point of concurrency, or point of concurrence also we can say. And what are those lines called? The lines are called concurrent lines. Concurrent lines. So the only difference between intersecting lines and concurrent lines is both intersecting lines will pass to the same point and concurrent lines also pass to the same point. But intersecting lines, how many should be there? Exactly two straight lines. But concurrent lines, more than two straight lines, we will call them concurrent lines. And sometimes the two lines are not sharing any common point, even if you extend infinitely many distances. Okay, like on the right or on the left, they're not going to meet. Such type of lines are called parallel lines. Such type of lines are called parallel lines. Okay, so the number of common points between parallel lines is 0 because they're not going to meet anywhere. Okay, so let us say this is line L and this is M. How to represent this mathematically? L is parallel to M. We can write L is parallel to M. So this symbol, how to read this symbol? Is parallel to, is parallel to. So we can say L is parallel to M. And in angles, in the next topic angles, we are going to discuss about right angle, but you people know about the right angle already. If the angle between two lines is right angle, then we say them perpendicular lines. Perpendicular lines. So if you say this is L and this is M, how to write this mathematically? We can write L is perpendicular to M. Inverted capital T. It looks like inverted capital T. So how to read this symbol? That is perpendicular to, is perpendicular to. Okay, L is perpendicular to M. So these are the relations between the straight lines. And yeah, more properties we're going to discuss in the next topic. So in these four concepts, any doubts you can raise a hand. So I'll clarify and move before moving to the next topic. Shriyash, any doubts?
Yes, sir.
What is that?
Sir, I don't understood this intersecting line, sir.
Intersecting lines you don't understand?
Yes, sir. If more than two lines intersect, how
Yes.
it will name, sir?
How it will name?
Yes, sir.
You can call lines separately, line L, line M, line N. But all of them are having common point O on them.
I want
That's
to
it.
use an intersecting line.
I didn't get your point. You want to use intersecting line?
Yes, sir. With symbol.
Which symbol?
Yes,
You
sir.
can use this. Between two lines, you can say like this. L is not parallel to M, you can say. Why? Because on a plane, for two lines, there are only two cases. Either they are parallel or they are intersecting. Is there any other case possible between them?
No, sir.
If they are not parallel, definitely they are going to intersect, right?
Yes, sir.
You can say L is not parallel to M. That means L is intersecting M. Okay?
Okay, sir.
That's it?
Okay, sir.
Okay. And Nishika, what's your doubt? Nishika,
Sir,
any doubt?
yes, sir.
Tell me.
Sir, what is concrete lines?
Concurrent lines means, see, only two lines are passing through the same point. We are calling them intersecting lines. But if more than two lines are passing through the same point, more than two means either it may be three lines or four lines or five lines, any number. More than two, any number of lines are passing through the same point, then you should not say intersecting lines. You should say concurrent lines. And the common
Okay,
point is called point of concurrency. That's it.
okay, sir.
Okay. And Harshavardhan,
Sir,
what's your doubt?
sir, when more than three lines are intersecting, what we call, sir?
More than three lines.
Yes, sir.
There is no separate names for more than three, more than four. More than two, all together we call concurrent lines only. Suppose if three
Sir,
lines are passing through the same point, concurrent. Four lines are passing through the same point, concurrent, like that, any number. Okay?
sir, parallel means?
Parallel means they are not going to intersect. So you see this figure, L is parallel to M. Even on extension, they are not going to meet, right?
Sir, intersect means they will
Yes?
meet in a spot.
Come again?
Sir, intersect means they will meet in a spot.
Yeah, that's it. That spot we call point. That point is point of intersection.
Okay, sir.
That's it. So this is about the straight lines. Now one important concept we are going to discuss, that is angle. Okay. So based on angles, you have so many questions in the previous year papers. Okay. So this topic is very important as per Sainik syllabus. So all of you concentrate. We are going to discuss what is angle. Okay. So what is angle? Angle means it is the union of angle means it is the union of two rays with common initial point. The union of two rays with common initial point. We call it angle. Let's say there is a ray here, and let's say there is a ray here. We already discussed about ray. What is ray? It starts from a point and extends towards one direction infinitely. Okay. So let us say this ray, I'm calling the initial point as O, and I'm calling the this point is A. And on the other ray, the ray starts from O and extends towards B. So there are two rays here, you can see ray OA and ray OB. So what is common between them? Their initial point. The initial point of ray OA is O, and the initial point of OB is also O. So they have a common initial point. Now, mathematically, this setup is called an angle, and it is denoted using a curve here. Okay, this one, and denoted by angle symbol. This is angle symbol. Okay, angle AOB. Okay, this is the name of the angle, or we can also reverse the order, no problem. So angle BOA, angle AOB, angle BOA, both are nothing but the same angle. And sometimes whenever the other 2 points are not important, we can simply say angle O also. Okay, so but the middle one is very important. So the common initial point for the angle, we call it the vertex of the angle. So what is the point O called? It is the vertex of the angle. And the two rays are there, no, they are called arms of the angle. One is called the initial arm, one is called the initial arm. So ray OA is called the initial arm, and this is the direction of the angle, and this is called the terminal arm. Terminal arm means where the rotation stops. So initial arm and terminal arm. And this is about the angle setup and the parts like vertex, and we call also the parts of the types of the arms, initial arm and terminal arm. So this is about naming the angle. And after giving the definition, next what are we going to do? Yeah, we can start discussing about its measure. Okay, so what is measure of the angle? Measure of the angle means measure of the angle measure of the angle means the amount of rotation, the amount of rotation required by the amount of rotation required by initial arm to coincide with the terminal arm, that amount we call it the measure of the angle. Okay, see, um, suppose this ray OA is there. Yeah, some people are asking it's 3:30 and we want to start. So what I do is geometry is a big topic. Okay, so it takes nearly 2 to 3 days. So until we complete geometry, let's stop the other subjects. First, let us complete geometry mensuration, because these two are very important topics and you are expected to have minimum 5 to 6 questions in a paper. 6 questions means 16 to 3, 18 marks. Okay. So first let us complete geometry and mensuration, then go for the revision of other subjects. I'm continuing geometry today up to 4 o'clock. Okay. So the amount of rotation required by initial arm to coincide with the terminal arm, that amount we call it measure of the angle. And how it is denoted? We write M. Before that, M shows measure. So measure of the angle AOB. And what are the units? What are the units? That is a question mark. So this question we are going to answer now shortly. Okay, that is the unit of the angle, how to find the angle unit and how to measure it. So before we go for the measuring the angle, any doubts in this angle definition and measure of the angle? Pranay?
Sir,
Any doubts? Yes. Pranay?
sir,
Yeah, what's your doubt?
sir, how we know? Sir, if sir, you said this, sir, measurement.
Measurement I'm going to discuss now. First, you tell me about angle. I said union of two rays with common initial point. No, in that any doubt you have?
Sir, no, sir.
Okay, measurement, you just wait for a while. I'll discuss after that, you can ask. So let's discuss about the measurement of the angle. Okay. So there are many units for measurements of angle like degree, grades, and radians. But in your syllabus, you have only degree to deal with. Okay. So first, let's have um, a ray. So there is a ray like this, and what we are doing is we are making the ray to revolute about itself by taking this fixed point. The point will be at the same place, but the ray is going to complete one full rotation like this. Okay, it starts at the same place and it ends at the same place. Starting from here to here, it rotated. One full rotation is over. Okay, that full rotation we are going to divide into 4 equal parts. That full rotation we are going to divide into 4 equal parts like this. Okay, and the full rotation we call it the complete angle. We call it the complete angle. So one complete angle is divided into 4 equal parts, and each part is called one right angle. So we call one complete angle is equal to 4 right angles. As you can see, each right angle, if you take this is in L shape. Okay, so right angles are identified by L shape. So all the others are angles are shown with a curve, but right angles are shown with this. Okay, like L shape, L band. Okay, that is right angle. And what we do is we take any right angle. I'm taking this right angle. Okay, in this right angle we are going to divide into 90 equal parts. 1, 2, 3, 4, 5, like that. How many equal parts I'm dividing? 90 equal parts I'm dividing, and each part, that means these are the rays. Okay, any two consecutive rays you can take, between them small angle is there, no, that is called 1 degree. This is called 1 degree, this is called 1 degree, this is called 1 degree, this is called 1 degree. Like that, in one right angle, how many degrees are there? One right angle, we have 90 degrees. So degrees means we use a like a it's like a zero, but it's not 90 power 0. In geometry angle measurement, we have to call it degree. 90 degrees. Okay, so one right angle is equal to 90 degrees. So if you know what is right angle, then we can discuss about the types of angles. Okay, so now we can discuss types of angles, the most important topic. So based on types of angles, every year you'll get 2 to 3 questions. Okay, so now types of angles. Types of angles. So generally angles are shown with a variable called theta. It is a Greek letter. It is used to denote angle. Okay, so let's start with the first type, that is zero angle. So what is zero angle? Okay, there is an initial arm, but the initial arm has not started its rotation. Initial arm is there, terminal arm is also there. I'm drawing only one arm. Why? Because both of them are coincided on each other. We cannot see them separately. Okay, here the value of theta is going to be 0 degrees because the rotation has not started. That is zero angle. In when zero angle is there, initial arm and terminal arm are going to coincide. And next, second one, acute angle. What is acute angle? Acute angle means here is the initial arm, and this is the terminal arm, and this is the rotation required. Okay, the rotation required, this if you call this is theta, and theta, the angle is more than 0 degrees but less than 90 degrees. Just now we learned about 90 degrees. One right angle is 90 degrees. So I'll show right angle here with dots. So this is the right angle now. You can see this theta is less than the 90 degrees. That's why it is called acute angle. It should be more than 0 degrees and less than 90 degrees. Then it is called acute angle. So what are the examples of acute angle? 30 degrees acute angle, 40 degrees acute angle, 45 degrees acute angle, until 89 degrees, 89.5. Whatever angle is there, which is more than 0 and less than 90, we call it acute angle. And then right angle. Right angle we already discussed just now. What is right angle? Having exact measurement 90 degrees. Next one, right angle. What is right angle? Here is the initial arm and here is the terminal arm, and they're making a right angle. Right angle is denoted by this L band. Okay, a complete angle is there. It is the fourth part of the complete angle. So if theta is exactly equal to 90 degrees, we call it right angle. And next, fourth one, it is obtuse angle. What is obtuse angle? So this is the initial arm and this is the terminal arm. Now you see the amount of rotation required. It is more than a right angle and less than two right angles. Okay, so the angle between one right angle and two right angles, we call it obtuse angle. So what we can say, theta is more than 90 degrees but less than 180 degrees. 180 degrees means two right angles only. So any angle lying between 90 degrees and 180 degrees, we call it obtuse angle. So 91 degree obtuse angle, 90 to 100, 130, 140, and any angle less than 180, more than 90, we call it obtuse angle. And next, after obtuse angle, we have the straight angle. In the name only it is there, it is straight. Straight angle. So what is straight angle? So this is initial arm and this is terminal arm. As you can see, they formed a straight line. Okay, so this angle, this amount of rotation theta, if it is exactly equal to 180 degrees, then we call it a straight angle. And there is a note point. What is a note point about straight angle? One straight angle contains how many right angles? Two right angles. One straight angle is equal to two right angles. One, because one straight angle is equal to 180 degrees. Two right angles, 2 into 90, 180. So you can see visually also, if you draw a vertical line above this point, this is a right angle, this is a right angle. That means two right angles together is going to become one straight angle. So straight angle measurement 180 degrees. And sixth type of angle, that is reflex angle. What is reflex angle? So here is the initial arm and here is the terminal arm. As you can see, the amount of rotation crossed even straight angle. Okay, that means any angle theta, if it is more than 180 degrees but less than 360 degrees, then it is called reflex angle. It should be more than 180, but it should not cross 360 degrees, then it is called reflex angle. What are the examples of reflex angle? I have 200 degrees reflex angle, 300 degrees reflex angle, 359 reflex angle. Any angle between 180 and 360, we call it reflex angle. And next, after that, complete angle. So this is the last one, complete angle. So initial arm is here, then it start rotated. That means it's going on rotating and it is the same position, the initial position. After complete rotation, it reached its same position. Then we cannot see the second ray because both of them are coincided like zero angle. But how to differentiate zero angle and complete angle? Zero angle, we have not shown this symbol of rotation, but complete angle, we are showing the symbol of this rotation. That means theta is going to be exactly equal to 360 degrees. Then it is called complete angle. So here also you can write one note point about the straight angle, that is one complete angle. One complete angle contains how many right angles? Four right angles, because 360 is the fourth multiple of 90. Four right angles. And you can also say one complete angle and one straight angle relation. One complete angle is equal to how many straight angles? Two straight angles. So visually, how can we identify one complete angle contains four right angles? See here, you draw it like this. 1, 2, 3, 4. So one complete angle is containing how many right angles? Four right angles. Then how many straight angles? If you just divide the complete angle here, this is a straight angle and this is a straight angle. That means one complete angle is containing two straight angles, because 360 is equal to 2 times 180. So these are about the types of angles. Okay, so till here any doubts you can ask, then we will take questions, previous year questions on these types of angles. Siyansh?
Sir,
Yes.
sir, what is the meaning of theta?
Theta is a Greek letter. Okay, I told you, no, the Greek letters are there, alpha, beta, gamma. In this list, theta is also a letter. Generally, it is used to show angles. Okay, more than
Okay,
mathematics, we use
sir.
that in physics. Come again.
Only meaning I am asking.
See, what is the meaning of English letters A, B, C, D? They are simply alphabet, right?
Yes, sir.
Similarly, this is also alphabet in Greek language. That's it.
Okay, sir.
But we are using to show angles.
Okay, sir.
Okay, next. And Harshavardhan,
Sir,
what's your doubt?
sir, coincide means?
Coincide means one upon the other. Okay. Suppose if
Sir, here.
suppose uh, two twins are there, twin brothers. Okay, they are identical in say shape and size. Okay, if one person is standing behind the other person, their size is exactly matched. Okay, exactly behind they are standing. So I thought that only one person is standing, right?
Yes, sir.
That
Sir,
means they coincided. I cannot see the second person. They coincide their position. Okay,
sir,
Bhuvana. Yes, Bhuvana.
Sir, why we use Greek letters?
Greek letters, actually we can use the English letters also. In place of theta we can use x also, but it is habituated in most of the mathematical articles and the mathematics papers, even the textbooks, and as a habit we are using, that's it. There is no particular reason. Okay,
Okay, sir.
so this is the types of angles and questions on this topic. We have 2023 paper, we have a question on types of angle, that is Name the type of an angle whose measure is 29 degrees more than the difference of 136 degrees and 77 degrees. Who is going to answer? Raise the hands. Very simple question. Only one student is raising the hand. Now you know about the types of angle, right? Only one student is raising the hand. Is it that difficult question? That can you read the question? That
Sir,
yes, read the question.
name the type of angle whose measure is 29 degrees more than the difference of 330, 136 and 77.
Okay, how to write this mathematically?
Sir, the 29 degrees plus
29 degrees more than. More means plus. Yes,
bracket
very good. Bracket.
136 minus 77.
136 degrees minus 77 degrees. Very good. So it is 29 degrees more than the difference between 136 and 77. Now can you simplify this, Daksh?
Yes, sir.
First you do, V board mass simplification, right? What should be simplified first, bracket or addition?
So bracket
Okay, 136 minus 77, how much?
59.
Yes, 29 degrees plus 59 degrees. Okay, what is the sum?
The 88.
88
88.
degrees. Now they are asking the type of the angle, 88 degrees. 88
The
degrees, which type of angle?
acute angle.
Why? Because 88 degrees is more than 0 degrees and less than 90 degrees. So any angle lying between 0 and 90, which type of angle we call?
The acute angle.
Yes, acute angle. Which option?
Option A.
Yes, it is A. Very good, Daksh. So this is about this question 2023. And next 2023 exam we got this question, that is, which of the angles in the given figure is larger than two right angles? Simple question. Who is going to answer this? Which of the angles in the given figure is larger than two right angles? Abhyuday, read the question. Bhuvana, Bhuvana, read the question.
Which of the angles in the
Bhuvana, read loudly.
which of the angles in the given figure is larger than two right angles?
Okay, what do you mean by two right angles, Bhuvana?
Sir, it is 180 degrees.
Yes, 180 degrees. 180 degrees is nothing but straight angle, right?
Yes, sir.
Okay, there are four angles in the figure A, B, C, D. Which angle do you think is more than one right angle?
Sir, C.
Only C, or any other angles are greater than 180 degrees?
Sir,
Say confidently, even if it is wrong or correct, no problem. Say confidently. Do you think any other angle is more than straight angle?
sir, no.
No, correct answer. So answer is only C. Only C. Which option, Bhuvana?
Sir, option C.
Option C. Uh, Through the figure also we can identify C is more than two right angles. We know two right angles means what? 2 into 90 degrees, that is equal to 180 degrees, which is a straight angle. So I can create a straight angle here by extending this line. Okay. So this is 180 degrees, but you can see in the figure C is greater than 180 degrees. So greater than 180, that is only option C. Okay. So the answer is C. Very good, Bono. You can mute. So this is about this question. So it is, which type of angle is this? It is more than 180 degrees but less than complete angle. We can say it is a reflex angle. And next question is here. How many acute angles are there inside the given figure? How many acute angles are there inside the given figure? Yes, Pranay, read the question again.
How
Pranay,
many, how
yes.
many acute angles are there inside the given figure?
Okay. Pranay, what I do is I'm drawing the figure again and I am giving some vertices for you. Okay. Let us say this is A, B, C, D, E. Okay. Whichever angle you think acute, you have to say its name. You understood naming of the angle?
Yes, sir.
I'll give an example for you. If I want to
Sir,
say the acute angle, so what is the name I should say? Angle BAC, right?
yes, sir.
Like that, you tell me. Angle BAC, I gave one answer. Next. Any other acute angle?
BC.
Very good. ABC. Next.
Angle DEC.
DEC. Next.
EDC.
EDC. Next. So you got four.
Yes, sir.
No other acute angles. Pranay, what is your answer?
Sir,
Is it option A?
sir, no, sir. Option B, but two angles are.
Where are two more acute angles? You are saying option B, but you are not saying where are they? Where are they? Pranay,
Sir,
Pranay, am I audible? Where are the other two angles? Acute angles.
sir, EAB.
EAB is the same angle. Don't repeat the angle again. Can I say DCE? Is this not an angle?
Sir, yes, sir.
DCE. One more.
Sir, ACB.
That's it. Any other angles left here?
Sir, no, sir.
No. How many acute angles we got?
6.
Six. Option B. Pranay,
Sir,
you are not identifying those two angles. That much difficult.
sir,
No.
ABC, that I don't. Sir,
Number of acute angles we got it equal to six.
sir, I want to say.
Names of the angles also you can see in the solution. As you said, CAB, ABC, ACB, everything is covered here. So it is answer B.
Sir, I want to say direct to
Okay, no
see.
problem. 2022 exam, we got this question. Identify the angle created by the minute hand and hour hand at 2:30 p.m. Who is going to answer this? Only 5 hands I can see. There are 19 students in the class, and remaining 14 students are keeping quiet. Yes, Bhuvana, read the question again.
Identify the angle created by the minute
Bhuvanas,
hand and
read loudly, Bhuvana.
identify the angle created by the minute hand and the hour hand at 2:30 p.m.
Okay, I'm drawing the clock face. So this is the clock face. 12, 3, 6, 9, 1, 2, 4, 5, 7, 8, 10, and 11. Okay. Now show me where is the hour's hand. Hour's hand is pointing towards which number at this time?
Sir, 2.
Wrong answer.
Sir, between 2 and 3.
Yes, exact halfway between 2 and 3. See, 2 o'clock, exactly 2 o'clock, our hand shows towards 2. But after that, each and every moment, our hand also has the moment, a little moment, not as the same moment as the minute's hand, but it moves 60 times less moment. So at 2:30, it shows exactly between 2 and 3. So this phase, okay?
Okay, sir.
Now, where is the minute's hand?
Sir, at 6.
Yeah, it shows exactly 6. Now, what are they asking? Identify the angle created by the minute hand and hour hand.
Yes, sir.
So this angle we want. So how can we find that? They are not asking you the measure. Okay, they are asking only the type. Which type of angle is this? Is it looking like a right angle?
No, sir.
No, very good. Then it is looking like which angle?
Sir, obtuse angle.
Yeah, acute angle is wrong answer.
Sir,
Bhuvana,
obtuse
what is
angle.
acute angle? Acute angle is less than right angle or greater than right angle?
Sir, I told obtuse angle, sir.
That's why you should read loudly. You're speaking with very low voice and I'm not able to understand. Yeah, obtuse angle is correct answer.
Okay,
Obtuse
sir.
angle's measure is greater than right angle or less than right angle?
Sir, greater than right angle.
Very good, very good. Correct answer. It is obtuse angle. So option B. Bhuvana, more than the type of angle, if I ask you the measurement also, what is the measurement of this angle? Not only Bhuvana, all the other students also try this question. They only ask the type, it is obtuse. But if you want the measurement of the angle also, how many degrees? What is the answer? Bhuvana, first you try. Bhuvana, you know the answer? Or you want time?
Sir, no, I want time, sir.
Okay, keep trying. If you get the answer, raise a hand again. Who will answer the question? How many degrees between the minutes hand and hours hand? Sriradhya.
Sir, between 90 and 180, sir.
Not between. I want exact number. Yeah, what you said is correct. Between 90 and 180. But I want the exact number. How many degrees?
Sir, I will try and tell, sir.
Okay, you can try. Abhyuday.
Sir,
Yes.
sir, 110.
110. Wrong answer. Try again.
Okay,
Okay, Abhyuday, you can try again. Pranay, what's your answer?
sir.
Yes.
Sir, first, sir, can you draw a right angle?
Okay, already up this angle is there. Where I have to draw the right angle?
Sir,
No
sir,
problem. No problem. No need of drawing anything. You got the answer. Say the final answer.
sir, 135
One,
degrees.
135 degrees. Wrong answer. Harshavardhan. Harshavardhan. Harshavardhan, you're not audible. Sriyansh.
Sir,
Yes.
sir, it is 105.
Yes, 105 is correct. Sriyansh, can you explain how?
Sir, 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 you move somewhat down. It made right angle, sir. Right angle is
Wait a minute. I will zoom this. Okay. Yes, Sriyansh. Now you can explain.
Sir, 2 to 3, there are 12 numbers, sir. Sir, 12 numbers is equals to 360 degrees. Then x is
Sriyansh,
equal
Shreyash, your answer may be correct, but your wording, I told you already the number of fingers and the number of gaps. Here, the gaps are important or the numbers are important?
sir, gaps.
Gaps. See, because it is arranged in a circular arrangement, the number of objects and the number of gaps are equal. Okay. But if you say you remember that type of questions like there are some number of trees planted 1 2 3 4, there are 20 plants like this, and you divided by 20 and you got the wrong answer. Do you remember that solution?
Yes, sir.
There you have to suppose if there are, okay, let us say there are 4 trees only here. Okay, and
Okay, sir.
I said that the total distance between the first tree and the fourth tree is something like 12 meters. Okay, what is the distance between each consecutive tree?
4 meters.
Come again.
4 meters.
4. You divided 12 by 3 or 12 by 4?
12 by 3.
12 by 3. Now you tell me what is this 3? Number of gaps or number of the trees?
The number of gaps.
Number of gaps. Here also you concentrate on the gaps only, not on the numbers. Okay. So though you got correct answer, but the wording should be, you should say number of gaps. Okay.
Okay, sir.
Now continue.
Sir,
Continue.
there are 12 gaps.
Okay. Very good.
So 12 divided by 360 is equals to 30.
Okay. Will you divide 12 by 360 or 360 by 12?
See, 360 by 12, sir.
Okay. The complete angle is 360 degrees and you're dividing by 12. Okay.
Sir, is equals to 30.
30. Okay.
Sir, so 30 into 3 is equals to 90.
Okay. That means you are dividing this complete angle into two parts. I think you are dividing like this up to
Yes.
3. Okay. So we know this is right angle already, right?
Yes.
And this angle, let us extend like this, and this angle we want to find. Okay.
Sir, 30 is half of 1 hour. Then
Very good. Yes.
small clock between 2 and 3, sir. Exactly between 2 and 3, sir.
Yes, that means it is 30 degrees divided by 2. So this is
Yes.
15 degrees, and this angle is already, we know, 90 degrees. So 90 plus 15 is going to be 105 degrees, right?
Sir.
Yes, very good. That is obtuse angle, and the measure also is it correct answer, 105 degrees. Okay, Sriyash, you can mute yourself. So in the textual solution also they have calculated the angle. Actually, if they ask only the type of angle, no need to calculate the measure. Directly you can say obtuse angle because it is just more than 90 degrees. But if you want the exact measurement, you can go in this method. So it is 105 degrees. Now, 2021 exam, you got this question. Write the name of the angle formed when the clock time is 7:15 p.m. So similar question. So be ready. I'm going to ask the measure also. So all of you try this question, and who is interested. So this is the last question of today's class. Try this question, all of you. Who is going to answer? At 7:15 p.m. Meanwhile, I'll draw the figure. Yes, who is going to answer? So only Sriyansh is raising the hand. What about the remaining? Already Sriyansh answered the similar model. What about the remaining students? Daksh is raising the hand. Rishika, Bhuvana, Abhyuday, Pranay, Shiradya. Still trying? Okay, Daksh, you can try. Daksh, read the question again.
Write the name of the angle formed when clock time is 7:15 p.m.
Okay, 7:15 p.m. The hours and will show towards which number?
So 7.
Exactly 7?
Yes, sir.
Is it exactly 7?
Exactly.
7 at 7:15 p.m. The hours hand show or it sees exactly 7.
No.
See, at exactly 7 o'clock it shows towards this number 7. But if 7:15, that means 15 minutes are passed. In that 15 minutes time, our hand will move or not? Daksh, otherwise let me ask like this. 15 minutes is how much part of 1 hour? 15 minutes is how much part of 1 hour?
The one. The
1
1/4.
fourth. 1/4. Very good. That means in this 1 hour, that means the duration between 7 and 8 is 1 hour. It moves 1/4 part of that distance, right?
Yes, sir.
That means where it shows 7 or 8 or somewhere between 7 and 8, or you know any exact position?
Sir, between 7 and 8.
Which position? Half, halfway? Is it halfway?
No, sir.
Where? Just now you told no, 1/4. That means how many parts should be divided?
Sir, 4.
That means 7 to 8. I'm dividing 4 parts like this. Okay.
Yes, sir.
Okay. I'm naming this as A. I'm naming this as B. And naming this as C. Now, towards which letter the R sand will show?
Sir, A.
Very good. So it will be something like this. Okay. Our sand is seeing towards which number? A. Okay. Now, what about the minute hand?
Sir, sir, 3.
Very good. It shows towards 3. Okay, this is minute hand. Now they're asking name of the angle formed when the clock time is 7:15 p.m. So first we don't check the measurement. You just tell me just by seeing the figure which type of angle is this?
Sir, obtuse angle.
Obtuse angle measurement. Can you say the definition of obtuse angle?
Sir, more than 90 degrees, less than 180 degrees.
Yes, it is option C. But now, if you get the same question at 7:15 p.m., find the angle between hour hand and minute hand. What you will be doing? Daksh, you want time?
Yes, sir.
Okay, you can try. Still, any other hands are raising? Yes, Pranay. Pranay, can you answer this?
Sir,
Yes. Pranay,
sir, I know angle of this. Exactly.
you got the answer, but you cannot say exactly, right?
No, sir, exact measurement I can't.
Measurement. You want time to try?
Yes, sir.
Yes, continue. Yes, what about Rishika? Rishika? Rishika, are you there? Okay, Sriyash, can you answer?
Sir, 127.5.
Okay, let us go through the steps first. So, what is the first step that we will be doing?
Sir, first step 30 into 4, sir.
Okay, that means you are counting these gaps, right? 1, 2, 3, 4. Am I right?
Yes, sir.
Every gap corresponds to how many degrees?
30 degrees.
30 degrees. So you got 4 full gaps. So it is 4 into 30 degrees. Now, but some part is missing in this. What is that? How much part of the gap is missing?
Sir, 1/4.
Yes. Now, what is the addition term?
1/4 into 30.
Very good. 1/4 of 30 degrees. Now you have to just simplify this. That's it.
Sir, 120 plus
Yes. 120 plus.
7.5.
Okay. 120 degrees plus, that is 50 by 2, and you're writing in decimals form. That is 7.5. So what is the final answer?
127.5.
127.5 degrees. And clearly, by number also we can say it is obtuse angle. So exact measure is 127.5 degrees. Okay. So that's it, students, from today's class. And tomorrow also we'll continue with geometry, and hopefully we'll complete this chapter tomorrow. So all of you, without wasting time, revise all the things, whatever chapter or whatever particular subject, which type of chapter you are losing the marks, concentrate on that and try to revise everything. And so whenever time permits, ask doubts, and even recorded lectures are also available for the previous chapters. So you have to plan well on your own. Okay, so which part you are losing the marks in the grand test, and you can plan well so that you can revise that particular thing. And tomorrow I'm conducting the test, I told you already. Okay, so tomorrow I want everybody to improve your score. Okay, so that's it, students. Thank you for joining. You may leave the class now, all of you.